In this video, we talk about data representation in computer system. So in computer system, bit is the most basic unit of information. So that's the state of on or off in a digital circuit. Or sometimes the state are high or low voltage instead of on or off. By another group of 8 bit and by the most smallest possible addressable unit of computer storage. The term addressable means that a particular byte can retrieve according to its location in memory. Uh, Beside byte, we also have a word. It's just a contiguous group of bytes. So word can be any number of bits or bytes. So basically, the word size is a 16, 32, or 60 bits are the most common one. The word addressable system is a word where the word is the smallest addressable unit of storage. So um, a group of 4 bits is called a nipple. So bytes therefore consist of two nipples, the high order nipples and the low order nipple. So in computer, we have the positional numbering system. Byte store number using the position of each bit to represent a power of 2. So the binary system is called a base 2 system. Now a decimal system is the base 10 system. It uses power of 10 for each of the position in a number. So any integer quantity can be represented exactly using any base radix. So here's an example of the positional numbering system. The decimal number value of 947 in power 10 can be represented by a 9 times 10 power 2 plus 4 times 10 power 1 plus 7 10 times 10 power 0. So basically that the positional numbering, because the 7 right here with the position of 0 with the index of 0, so that's why we have the 10 power 0. 4 have the index of 1, so that's why we have the 10 power 1, and the 9 have the index of 2, so that's why we have the 9 times 10 power 2. Now the decimal number is 5,836.47 in power 10. We can represent it as follows: 5 times 10 power 3 plus 8 10 power 2 plus 3 times 10 power 1 plus 6 10 6 times 10 power 0 plus 4 times 10 power negative 1 plus 7 times 10 power negative 2. Okay, so this is because the index of 6 equals 0, 1, 2, 3. So that's why we have the 5 times 10 power 3, and then 8 times 10 power 2, and 3 times 10 power 1, and 6 times 10 power 0. The decimal point right here represent the break point, where after this one gonna have the negative 1. So basically 4 gonna time with 10 power negative 1, and this 7 have the index of negative 2, so that's why 7 times 10 power negative 2. So that's the positional numbering representation. Similarly, we also have the positional numbering system in binary number. For example, consider number 11001 in power 2 gonna be represented as follow. Similar in the decimal number, we have the first digit right here. That's the index 0, index 1, index 2, index 3, and index 4. So we can represent this number in binary by using the representation in positional numbering system. That 1 right here time with 2 power 4. So because this number 1 right here have the index 4, and that's why we have the 2 power 4. 2 is mean the binary base. Then the second digit right here, that's 1. So we have the index of second digit right here, have the index 3. So that's why we have the 1 times 2 power 3. The next digit right here have the index 2. So this value right here is a 0 times 2 power 2. The next index right here is a value of 0. So we have the 0 times 2 power 1 because this 0 have the index 0. And the last one right here have the value of 1 times 2 power 0 because this one has the index of 0. So you can see that the position of the or the index of the digit gonna be uh, used to calculate the value of the number. So basically, if we transform this one into a decimal, we can see that 2 power 4 equals 16, 2 power 3 equals 8, 2 power 2 equals 4, but we multiply with 0, we get 0. This one also we get 0, and this one 2 power 0, we get 1, 1 times 1 equals to 1. So we add them up, we get the value equal to 25. So in binary, the string 1, 1, 0, 0, 1 will be equal to 25 in decimal representation. So when the radius of a number is something other than 10, the base is denoted by a subscript. Sometimes the subscript 10 also added to for emphasis. For example, this string is the number represented in binary will be value of 25 in decimal. Okay, so the subscript right here just emphasize the base or the radius of the number we represented.